talking about solutions of differential equation and what they stand for, let's talk about one of the process that will allow us to solve simple differential equations. We have here the process of eliminating arbitrary constants. This is one method that is actually useful when you have a very simple what they call this one equation, differential equation, and it has different arbitrary constants. The arbitrary constants here are actually illustrated by either variables, let's say c or a, and so on and so forth. Now, in the presence, their presence in differential equation can be removed and will give us the result for the intended output. Now, let me try to provide here some ideas and concepts as to why we use this method, aside from the methods that will be presented as we dig deeper into this series. Let's say, for example, a very simple differential equation. The first order derivative of y with respect to x, let's say equal to 3x squared. Now, there are a lot of methods that will allow us to solve for this, but at the same time, the very first method that we can think of is actually trying to integrate both sides. We can start trying to multiply both sides by d of x, or dx. So we will have here dy is equal to 3x squared dx. So we multiplied both sides with dx. Then we can actually apply here the integral of dy is equal to the integral of 3x squared dx. Of course, the integral of y is just y itself. And here, using laws or rules of differentiation, you can take out the 3 as a constant. The integral of x squared dx, which will give you 3 times x cubed over 3. Okay? Then you will get here a result which is actually y equal to x cubed. This is the solution, or one of the solutions, one of the solutions for the identified differential equation here. Why do I say one of the solutions? Because don't forget that once we take the integral of a function, we always add here c, which refers to any constant. And that would mean it could take values of +1, -3, we have 1/2, or square root of 5, or in this case, if you're going to stick with that, our c is just equal to 0. Now, all of this, if you have another form here, y is equal to x cubed plus 1, y is equal to x cubed minus 1/2, and of course, y is equal to x cubed, where your c is 0. When you take the derivative of this, or when you differentiate all of these three, they will actually give us this result. The point here is, when you talk about adding a certain constant c here, you're actually talking about a lot of possible solutions. So we try to come up with a process that will actually describe a family of solutions, not just for one particular case, and that is actually the method of eliminating arbitrary constants. In one of the process, this c here will maybe remove as we go through some specific process, like taking its first order derivative, taking its second order derivative, and then solving for solutions. We actually have some examples for that in the next few videos, but the point here is the method of eliminating arbitrary constants will allow us to actually represent the entire family of solutions and not just one particular case, because all of this and all of their versions for any value of c will actually get or have a derivative or first order derivative equal to this form when they are differentiated. So we'll have an example for this, or examples for this, on elimination of arbitrary constants as we try to solve for specific differential equations later on. So please stay tuned for that. Thank you very much for watching.